This section is going to be about JavaScript. You can pretty much master JavaScript in about an hour. We're not going to deep dive into every aspect of JavaScript. We're just going to give you enough that you need so that you can continue on learning QML and getting better at it. We've already covered some JavaScript, so some of this is going to be a complete eye roll moment where you're going to say, okay, I already know this. Feel free to fast forward or just skip the video entirely. I'm adding this in with the understanding that some people are going to come into these tutorials with absolutely zero JavaScript, or they know just barely enough, but they need to know a little bit extra. So first off, what is a variable? A variable is something that will change. It's actually a scientific term. We're going to use rxtester.com, and there's tons and tons and tons of online JavaScript compilers. I love being able to say something like this, and in virtually real time, bang, see the result down here. You can 100% do this in Qt Creator. I'm just doing this online because it's much faster. Now, there are some rules to variables, and I'm just going to copy and paste those out there. JavaScript identifiers, or variables, can contain letters, digits, underscores, and dollar signs. Names must begin with a letter. Do not try to begin with a number or anything else. However, one caveat, names can also begin with a dollar sign or an underscore. I typically shy away from that because I like to follow this first rule, must begin with a letter. Names are case sensitive. Cannot repeat that enough and enough. Lowercase and uppercase are two different variables. Reserved words, of course, cannot be used. And there's tons of different types. When I say tons, there's actually only about half a dozen. But anyways, you get the point. So 99% of the time, you're just going to type var, short for variable, and I'm going to say x equals 100. And let's go ahead and print x. Ta-da, 100 down here. Now, a variable being something that will change, you can do something like this. F8, and now we got 75. If I were to take this and make this uppercase, it's probably not going to work. Nope, error. See, x is undefined. Notice it's lowercase. We've defined an uppercase. All right, so variables, super simple, super easy to understand. You just got to get some ground rules down. JavaScript itself is very C-ish. And when I say C-ish, I mean it's very reminiscent of C and C++, and, well, Java is where it's coming from, so JavaScript. Meaning we're going to be dealing with brackets. Brackets denote scope. For example, bang and bang. Let's actually run that, see what happens. Notice how it continues to work even though we have that. So what we've done is we've actually created a scope. Now, anything not in those brackets is considered the global scope. Anything in brackets has its own scope. So let's demonstrate this. And we're just going to say, what do you think is going to happen here? We're declaring x multiple times. Well, look what happened. We have x declared in the global scope. We're saying x equal x minus 25, so it is 75. But then we're going into a scope here, and we're redeclaring x as 5. Printing x, 5. But then we're back in the global scope. So that's right, we had a naming conflict, so it overwrote it. Be very cautious when you create something on the global scope, because you can very easily overwrite it. To do that, you're going to use something called flow control, which we're going to start introducing in the next few videos. Probably the easiest of the flow control to really understand is the if statement, and it reads like a book. If this, then do something. So we're going to say if x equals 10, then let's go ahead and print a little bit of copy and paste magic here. Not equals, then we're going to say no. Pretty easy to understand. We can say that x is 10. If x is 10, if x is not 10, the exclamation means not. Very similar to C and C++. Let's go ahead and run this. Yes, it is 10. Now if I change this to, ta-da, it's suddenly not 10. Very close to it, but not exactly it. Remember, computers deal in precise numbers. Cancel. Don't know why I did that. So no, it is not 10. Now, remember our conversation earlier where if we had to do the triple, because these are two different types. This specific compiler in the background doesn't really seem to care, but in QCreator it got a little cranky with us and gave us a warning when we just had 2. So what's really the difference here? Well, using the 3 does not perform any sort of type coercion, meaning it doesn't try to figure out what sort of type it is. So 10.00 and 10 are two different types under the hood. Like I said, this compiler doesn't care, and usually you can safely ignore it. However, just be aware that is a thing, and some JavaScript compilers care and some do not. All right, moving on. We can also break it down to if-else, and we can use operators. So we can say, for example, if x is less than 10, then do something else, we can do something else. And it reads just like that. It's super simple, super easy to understand. I'm going to grab this. Less than 10. And we're going to say, instead of less than, I'm going to say less than or equals to. Greater than 10. Pretty simple to understand. And we can do, last but not least, the else if. So I can say if x is less than 10. And then we can say, I'm just going to do the less than 10. I should say less than or equal to. Then I'm going to say else if, and then we have to give it some sort of check. There we go. So if it's greater than 10, I'm just going to say, and then we can give it one final if, else, there we go. And we're going to just simply say equals 10. Save and run. And we get a whole lot of stuff going on here. You understand the basic principles. We can do a one-liner. We can do else if. We can do else if and else. Now, is this really an else if? When you read it, it says else, but under the hood, it is actually an else if. It's basically else if false. Basically, this didn't equal true. A little bit confusing. Some languages you have to specifically define that, and if you're coming from one of those languages, you might be a little bit confused. But basically, when you see else, it means else everything else was false. Let's take a look at some loops. Loops are a little bit more advanced in terms of flow control. So I'm going to say for, and this is going to be very, very reminiscent of C, C++, and Java. If you know any one of those languages, you already know this. And I want to include C# in that as well. And I'm going to say equals 0. I is less than 3. Do our incrementer. Should note. For loop is good for ranges, and I should probably capitalize that. So whenever you see for, think of a range. Let's go ahead and print this out. So what do I mean by it's good for ranges? We know its start position, we know its end position, and we know we want to increment or decrement. Let's run that. Bang, 0, 1, 2. The do loop, notice I added some extra zeros there, is dangerous. And here's why. The do loop will always run at least one time. You may be scratching your head going, wait, what? Watch this. So we're going to say var x equals 0, and then we'll say do, and then we're going to make our scope. And inside our little code block here, I'm going to say print x increment that. Now we actually do our logic check here. We're going to say x is less than 3. Now, someone not experienced in programming is going to go, oh, no, wait a minute. It's going to check to see. Yes, it does, but it's going to run it at least one time. Watch this. So I'll run it. It runs as expected. Change this to some absurd number. You're going to look at this and go, oh, it's only going to run if it's less than 3. Watch. Ran at least one time. Why? Because it's reading it from the top down and it's hitting this and going, okay, run this. Now, should I run again? Yes or no? That's what's going on. The while loop is much safer. Always checks first. The while loop basically takes the do loop, flips it upside down, does its check first, and it's going to say, it's actually, let's say var y equals 0. Let's go in here and say, we're going to run as long as y is less than 3. Just do a little bit of creative copy and pasting. All right, so variable y equals 0, as long as y is less than 3, run the scope of code, increment y, keep going. Let's run that, test it out. There's our y. Let's change this to some giant number, and let's watch this evaluate it first. There's no y, so it's working as expected. Big takeaway from this is there's many different types of loops. The most popular ones are for, do, and while. For is good for ranges, do can be a little bit risky, and while is kind of the de facto if you just need to keep going and going. Let's take a look at the switch statement. It's a little hard to wrap your head around if you've never seen it before, but because one of the prerequisites for this is C++ and Qt, I'm assuming you've seen it, but there's some caveats you need to be aware of in JavaScript. So let's take a humble variable x, call that 0, another variable y, say that is hello, and let's make a switch. Now, a switch is very simply, it's like a bunch of light switches. Think about like if you're walking down a hallway and you see a bunch of light switches, like 4 or 5. And we can say print 0. I'm just going to make a bunch of these real quick if I can figure out my keyboard. There we go. So we have a case, which is the actual switch. If it's 0, then do this. And then we have a break. This is meant so we don't have what's called fall through. Let's demonstrate that. And I'm just going to... Fall through is kind of from the legacy days here, where you could say, hey, 0, 1, 2. And you wanted to be able to say, well, if it's 0 or 1, I wanted it to do something. Notice how it's 0. Let's go ahead and comment this out and see what happens. Notice how it's 0 and 1. It's because we didn't break. We didn't break out of that whole scope. So if you don't want fall through, make sure you have a break. Also, one unique thing about JavaScript, I actually shouldn't say unique, but you won't get this in most other languages, is you can actually mix and match types for your actual switch. For example, you can say hello. Now, instead of switching on X, let's switch on Y. Notice we've got the same switch statement, and we have some numbers, but we also have a string. Let's see what happens here. Hello world. It just worked. That is incredibly flexible and very, very cool. And as always, you can have a default. Default is our way of telling the computer, I have no idea, just figure it out. And again, you need to have your break in there, or it will continue to fall through. You notice I have these little semicolons. Do we actually need those? Let's test that. We are switching on X, which is 0, so it should print out 0. So this one works. I've noticed in other JavaScript compilers, for some reason, break, you actually need that, and others just doesn't care. 99% of them out there are going to automatically put it at the end for you automatically, and you don't have to worry about it. So it might have been a bug in the one that I was working on. Default, again, is the I don't know. So let's say this is some crazy number. It's going to print out unknown. Ta-da! Just works. Switch is incredibly handy if you have something like a list of options you want the user to choose from, and then you don't want to make a billion if-elses. What if you want to do some if-else logic, but you want to put it all on one line rather than having a big gobbledygook of code? Well, the conditional or ternary operator is the only JavaScript operator that takes 3 operands. It's condition followed by a question mark, and then the true condition is executed followed by a colon, and then the false condition is executed. Let's go ahead and take a look here. So we're going to say var y equals, and let's jump up here and say var x, start with a value. Simple value of 15. Now, we want to know whether or not this is a specific operator, meaning is it greater than or is it less than? So let's say x less than 10. Is that true or false? And then we'd have to do some if-else, or we just say is it. Whenever you see that question mark, know that we're talking about the ternary operator. True, colon, false. That's the basic syntax. So it's going to go, hey, take y and then do some sort of evaluation. If it's true, return the first value, otherwise return the second. Let's go ahead and run. It is false because it is greater than 10. Let's do that again, but let's do it this way. And I want to say x greater than 10. And instead of bools, let's actually return strings, and we're going to say go ahead and print this out again. It is more than 10. It's very simple, very easy to figure out. You do some sort of evaluation, followed by the true value, followed by the false value. Now, as we play around with different things like flow control, you notice these little brackets. Well, those brackets actually denote scope. And let's demonstrate that. Notice those brackets? It means everything in those brackets is its own scope. So we have the outer or the global scope and the inner scope, which is part of this little function here. Function basically takes some sort of name, you can have a parameters list, and makes a scope block, and then you can do whatever you want in there. For example, we can just simply say return hello world. And then we can do something like this. Ta-da! So really what's going on under the hood, you guessed it, print is calling hello, hello is returning this string. And we can make this much more complex if we really wanted to. But at the end of the day, it's accomplishing the same thing. Ta-da! We could even do something like this. You're probably sitting here going, well, this is pretty obvious, but it's important to understand that scope is a real thing and it'll have a real impact on your application. All right, let's take a couple other real quick examples here. So I'm going to say function SQFT, short for square feet. And let's say we want X and Y. This is just going to simply return X times Y. Print, and I want to say, let's make a var Y equal SQFT, and I want 12 by 13. And then we're just going to go ahead and print Y. 156 square feet. Notice how we have X in here. If we didn't have scope, we would have some very real problems. What would be going on is we would be saying X equals hello, in this case hello world, and then we would be saying X is really hello world, so it's hello world times 13. And no, don't get confused by that. Whenever you see these brackets, know that it's its own internal scope. The scope actually starts up here rather than back here. We've just gleamed over some of the very basics. JavaScript is a language in itself, and it has grown immensely throughout the years. So w3schools.com has a really great JavaScript tutorial. I don't want to reinvent the wheel, so I'd highly encourage you to really learn JavaScript outside of this course. What we covered are the bare basics you need to continue on with this course and into the intermediate tutorials. But JavaScript has a lot more out there. For example, arrays, you can sort, you can iterate, dates, times, randoms, all sorts of really cool things. I mean, this is truly a language in itself. Now, some caveats to really be aware of is that the JavaScript engine is different. And when I say different, I mean it's slightly different from one vendor to the next. There's no universal JavaScript engine, meaning the JavaScript engine you run on, say, Microsoft Windows is different than the JavaScript version you run in, say, Mac or Linux. And to make it worse, the JavaScript engine you run in, say, the web browser Chrome may be different than the JavaScript you're running inside of, say, Qt Creator. Oh man, that gets frustrating. So as long as you adhere to the basic rules of JavaScript, you'll run into some little gremlins and caveats and differences, but by and large, everything should just work. We're going to take a look at an example of inline JavaScript. So we have this little box, and if we click it, it'll jump over here, and notice it changes colors when we click it. We've done something very similar before. Let's go ahead and take a look. Say rectangle, and let's go ahead and say ID box color. For now, I'm just going to say red. Width 100, height 100. Let's say X is going to be 0. Y is going to be a little bit more complex. All right, let's take a look, save run. There's our box. Now we need to animate it a little bit. And I don't even want to call that animation because it's more, you guessed it, just a mouse area. So we got mouse area. Let's go ahead and fill it. Now this is where we're going to implement two little JavaScripts. First off, the color, right? We're going to say if the area.pressed, notice the question mark, we're doing a ternary operator, and the colon, so if it's not pressed, we're going to say gray. This is a JavaScript property binding. Not a true property binding, mind you. We're just using JavaScript in the property. Now, we want to do in a signal handler. We've done this before. These should look very, very familiar. Sometimes using a ternary operator in a property is a little cumbersome, and QML does not always pick that up. So definitely test it for your specific version. I'm going to say print and let's go ahead and make a var. We'll say var max equals root.height. Now, we've talked about scope in JavaScript. We have an ID root, and because it's in the global scope, actually the global scope's up here, but it's in a upper scope, we can actually access it down here. That's how that works. So we've got scope here, scope here, scope here, scope here, and we can access it all the way up. Same thing with box. We can access that because it's right here. Ta-da! Works very elegantly. Now we're going to say box.x equals let's test this and see if it works. We've got a gray box, mouse down, turns orange, and ta-da! Pretty cool, pretty easy. Now, some things you should understand right off the bat here. Making mistakes is very, very simple. And because that is not a logical mistake, JavaScript and the Qt Creator ID are not going to catch it. That's where testing comes in. Uh-oh, we did a very big boo-boo. There we go, width. That could have been very, very bad. But that's what I mean. You have to do some testing. Don't always trust that Qt Creator or the JavaScript engine is going to catch your mistakes. I know I've said it before, but the beautiful thing about code is there's a million different ways to perform the same thing. We're going to create basically the same application functionality, but we're going to do it totally differently. Let's take a look. So we have our window. Let's go ahead and give it an ID of root. Now we're going to make our rectangle. Let's give it an ID of box. Again, we're pretty much rebuilding this whole thing here. We're going to say color. Start off with, it's going to be red. Width 100. Height 100. And let's go ahead and put this in our XY coordinate that we want. And we're going to put this at we're going to make our mouse area. Go ahead and fill our parent. There we go. And let's go ahead and let's make some functions. First one I'm going to do is I'm going to actually say swap color, and I'm going to put this right in the rectangle itself. And I'm just going to say function swap color. There we go. Return, and we're going to say area dot, did you catch that? Area is down here, but we can access it up here. So what's going on is whenever we have an ID, there's an invisible table up here that adds all the IDs up here. It does that so you can access those components anywhere in the QML document. It doesn't have to be on top of each other. Very, very cool. All right, so area pressed. And then we're just going to do our operator orange, or it's going to be gray. So now we've got this little function called swap color, and we need a place to put it. We're going to do it right here. Save and run. No. When we click it, it changes color. So our function's actually working. That is extremely cool. And because now we can put functions right in the property, well, you guessed it, we can just make this infinitely easier or more complex. Unfortunately, it's really on us to determine how we want to do that. Let's go ahead and let's make an external function. Now, when I say external, it's actually external from this rectangle. And I'm going to say perform click. And let's go ahead and say box color equal green. Gonna take this guy, go down to this mouse area, place your bets, place your bets. Do you think it's gonna work? Save run. It did. So what's happening there is when we create this, this also is above, so it can access it. Let's actually take this and put it underneath. Now, will it run? Knowing that scope is from top down, perform click has not even been defined yet. Let's take a look. It works. So you could do it that way. You could also, and I want to almost call this the preferred way, put it inside of an item. Call it code. And let's actually change this around. So we're going to actually implement the signal handler here. And this is pretty much the same code we had last time. So I'm going to say var max equals root.width minus box.width. Remember, if you switch those around and do height, that's not actually a syntax error, so it's not going to catch it. And we're going to say box.x equals now we can just simply go code.perform click. And that's how we'd call it inside of this item. So really we're just calling it inside of another object altogether. Save and run. And it works. Big takeaway from this video is once you start introducing the concept of functions and JavaScript and all of the complexities with it, you can make this as simple or as complex as you want to. And it's actually quite common that someone will email me and go, well, how do I make this work? And they send me some gigantic JavaScript file where it's like trying to calculate the position of the sun, moon, and stars, and all they need is something like this. Inline JavaScripts and functions are great, but what if you want to do some code reuse? Like if you want to put things in an external JavaScript file, you can, but there's a few gotchas. Let's take a look here. I'm going to make an empty app. Call this 10-11. And we're going to make basically the same application we've been making. So I'm going to just say ID root, and then I'm just going to just crank through this code because we've done this a bunch of times already. Color red. And let's set our XY position. So I'm going to say X0, Y. And let's say height divided by 2. Sometimes I get typing a little too fast and I get lost in what I'm doing. So we're going to add our mouse area, and I need to slow down just a smidge because IntelliSense gets super helpful when we get into there. Anchors fill. Parent, and now we want to actually implement this. So we want to do two quick things. First off, we want to be able to set the color, and we want to be able to track the press and move it around. Whew. All right, so save our work, right click, add new, and this is where we're going to start hunting through here. Well, under Qt, you can see there is this JS file, which is, you guessed it, a JavaScript file. Let's name this code. Don't want stateless, and just next, next, finish. It makes this little guy, and there's a function template already in there for us. And this is pure JavaScript without any of the complexities of QML in there. And I'm going to say print. Can just do the magic of copy and paste, one of the best things ever invented. And let's go ahead and var max, and this code should look very, very familiar because we've done this before. Now, I'm going to say root dot, and you notice how IntelliSense is not popping up and helping us here. This is something you could easily goof up. If root is never defined, you're going to get object not defined, but it will work because we're going to use it in here and root is defined. This is a major no-no. I'm doing it just to demonstrate that you can, although you really shouldn't. So the question becomes, if you shouldn't do this, what should you do? Well, you should actually pass it as a parameter up here. Notice how we're doing obj.width. You could actually put root up here. And I'm going to say obj.x. Notice how suddenly it's super picky and it doesn't want to do any type coercion. All right, so now we're back to this. That's that JavaScript engine kicking in, where before it wasn't doing it. All right, I'm going to put in a little comment here. So there's our perform click, and let's actually do a function called swap color. And obj press, you guess it, this is the mouse area that we're interacting with. And we're going to say all right, let's go ahead and wire these in. First thing we need to do, flip over to main, and we need to actually import. So we're going to say import code.js, and we have to say as, meaning we're going to actually create an object here. So what's happening under the hood is this is being loaded up into an item in the background for us, and that item's being called code. Going to put a little copy and paste action here. There we go. That way if you have any questions, and I'm going to put the link here just in case anybody wants to read it. JavaScript expressions for QML. Let's go ahead and wire this up. So now we can just simply say code dot ta-da, swap color. We're going to give it that area because if we read this, it is swap color is obj press. So it's obviously looking for a mouse area here. That is some of the problems right there with JavaScript, is there's really no type checking. So we could have passed it the rectangle and had some disastrous results. Likewise, we're going to demonstrate something here. So we're going to say on clicked, and we want code perform click, and I'm going to say box. Everything looks good, and if we save and run, assuming we typed everything okay, it works. It beautifully works. However, go back to our little JavaScript here. Remember I said don't do that. Let's change this. I don't know what to call it. Rudy, why not? Nothing's visibly broken, and it runs. But now it suddenly doesn't work. I'm clicking away and it's not moving. Why? Look at our app output. Reference error, root is not defined. That is why you don't do that. So realistically, what you should do is grab this. Now root's suddenly defined. We can go in here. Wow, I got a bunch of these open. Let's kill all those. And let's go with, that was under perform click. Save, run. Uh-oh, still not working. Why? Reference error, root not defined. You can see how you can easily get yourself into a trouble here. So once you start playing around with that, it's kind of a hole you can't dig yourself out of. We're going to flip that ID back to root. Now let's try it. Save, run. It magically works. Ta-da! Big takeaway from this is yes, you can put JavaScript in an external file. Do not use IDs in here. Always pass them as a parameter. Otherwise, you're going to run into some big problems. And when you put it into an external file, although you can access objects, they're not guaranteed to exist. Now we're going to take the gloves off. We're going to get down and dirty with this code. And what I mean is, we've talked about some pretty basic things, but we're going to actually start connecting JavaScript with back-end C++ handlers. And we're going to do that through QML. And what I mean by that is if you understand Qt and Qt Core, you know that it runs primarily on signals and slots. So what we want to be able to do is bind or connect a signal and a slot together using QML. And this is actually a little bit challenging. We're going to use the code from the last video. Save, run. Let's just demonstrate what this looks like. Ta-da! Same thing that we've been seeing. We have our code.js as code, and we're going to do some surgery here. And there's a couple little gotchas right off the front. So remember how I said never use an identifier, always use a parameter. We're going to be doing a little bit of surgery here. So kill two birds with one stone. I am going to show you also how to implement, you guessed it, a startup. So first things first, let's go in here. And we're going to say component.onComplete. There we go. So now that we got component uncompleted, let's go in here and let's make a startup function. And then it's just very simple. Save, run. See down here, starting JavaScript in handler. All right, so let's get this going here. What we want to do is we want to, well, take this guy right here and actually connect signals and slots. Now, to do this, it's going to be a little bit challenging here. So, first things first. What we want to do is actually say clicked. So we're going to say function clicked mouse. Now, how did I know to put the mouse in there? Let's jump back. Highlight that. Hit F1. Signals clicked mouse event mouse, meaning when this signal's emitted, the clicked signal, it's going to also have a parameter called mouse, which is a mouse event. And this is all taking place inside of QML. And we can actually just copy that. And if we wanted to, we could do something like this. Get rid of the type because we don't need it. And voila, that's kind of how we get to that point here. The problem becomes, what if we wanted to do something like this? Do you see the problem? If we're only being passed a parameter of mouse, how do we know what these objects are if we wanted to perform click? Well, we really don't. And that's where the complexity really jumps in, and then we get a lot of questions. So to solve this problem, we have to go all the way back to the beginning, our conversations about variables. We're going to make two variables right off the bat here. And then we're going to take our startup and we're going to say croot, cbox. There we go. Editor was trying to help us out a little bit. And then we're just going to say root. As long as those names line up, shouldn't have any problems. But now we can actually get rid of that and plug these in. So now when we call perform click, as long as these are already set up, it will work. Again, there's a million ways to do this. So now we need to wire up this onClicked. Let's take a look at how we do that. So you would immediately think that you would do something like this, onClicked equals something, but you would be dead wrong. And this is where it gets super, super confusing. What we're going to do is go in here and we're going to say area clicked dot connect. And IntelliSense is not going to help us out in the least. Code clicked, make sure we're not calling the function, we're giving it the function prototype, if you will. So area clicked connect, very, very reminiscent of QObject, and that's exactly what's happening under the hood is a QObject calling connection, and it's connecting it to the code click slot, which is actually being generated in the background automatically. Oh, that is nuts. All right, let's save and let's run. Something's going on. Let's see what's going on here. JavaScript and signal handler type error. What? So we got root and box, root width minus box width. Did we goof that up? We got root and box. Why is this suddenly an issue here? Well, let's take a look and figure out what's going on here. Ah, yes, we forgot this. That is one of the problems right there, is it's just not going to be super helpful. So I guess the point I'm trying to illustrate here is once you make a design pattern, stick with it. Because if you start changing things around, you're going to start getting a lot of really squirrely errors, and you're going to spend a lot of time, not even in debug land, just application output land, trying to figure out what the heck is going on. So some takeaways from this is, yes, variables are your friend. Do not really try to use identifiers from one file in another file, because if that identifier changes, it's going to break it. Running startup script is very, very simple. Just do component onCreated in your window, and you can connect signals and slots. But the big problem is the signature of the signal and the slot have to match, which then becomes the chicken or the egg problem. Okay, I'm going to level with you. I did not want to make this section. I didn't want to make this section because it's a bit more advanced than what this course was really meant to cover. But inevitably, somebody out there is going to say, hey, how do I connect C++ to QML? Can you explain that? And then we have a very long, exhaustive conversation. So I thought I would just add this section, which is going to go over the high level of how C++ and QML can integrate. So some disclaimers. QML lives on top of C++ and Qt. You can expose C++ classes to QML and vice versa. However, C++ is an advanced topic, and we will not be covering it in this course. It's actually a prerequisite for this course to already know C++ and Qt core. So if you're one of those folks going, I don't know C++, but I want to connect QML and C++ together, I would highly advise you to stop, go learn C++ and Qt core, and come back. All right, C++ and QML communicate via signals and slots. If you already know Qt and Qt core, you know exactly what that means. But yes, it means that all the goodness you've learned in Qt core, you can actually use in QML. Everything under the hood is a signal and slot. There's no extra technology you have to learn. It's actually building upon what Qt is already built on. It's actually really cool. So we're going to open the main CPP file, and we're going to explain what's going on. And I've already dumped a lot of comments in here, and I'm just going to walk you through it. So here are the includes, and it's pretty standard for any application. But we have the Qt GUI application, the QML application. Notice the double Qs. That kind of drives me a little bonkers. But the QML application engine, this is what actually loads all the QML scenes. So again, disclaimer, C++ advanced topic, QML lives on top of C++. Main, this is the main entry point of the application. Notice I said the application. This is actually a C++ application loading a QML file. So in effect, you are making a C++ app, you just have a nice QML GUI. All right. The Q core application, we're going to set the attributes and we're going to basically say enable high DPI scaling. High DPI scaling is for devices, for example, cell phones, Chromebooks, things of that nature, where you have high DPI visual displays. The application class, the QGUI application, this is your actual app. And you can see down here, this is the event loop. So basically, we create the app, we do some configuration, and then we go into an event loop, meaning the application just runs and runs. So let me demonstrate that. So as soon as you see this window, bang, everything's loaded, and now we're in the app loop. We're just waiting for the user to close the app, and then it would come right here. So everything in between, we call this configuration, but actually for QML, this is the heart of your application. The QML application engine, this is the actual engine that loads the script up and makes everything function. It loads it up using a, you guessed it, QString literal, Q resource content, main QML, meaning it basically just loads a string, this guy, out of the resource file into the engine and then runs it as QML. So in effect, it acts almost like a virtual hypervisor, if you will, or a sandbox loading the QML on top of Qt. Then we're just connecting some signals and slots, and we're basically saying, hey, make sure that the object and the URL equals the object URL. A little bit confusing, but basically what they're doing here is they're saying, make sure the engine loaded this correctly, and if it didn't, then hey, exit with status -1, meaning something bad happened. Very, very end of this, we're going to say, engine, go ahead and load the URL. If there's a problem loading that, boop, you guessed it, signals and slots are going to kick in. It's going to say QCore application exit -1. So if you ever go to run an app and it goes like that and then immediately just disappears, check your app output, make sure nothing blew up, and check the app exit status. If it's -1, you know you've got some sort of problem. This video, we're going to cover how to call a C++ slot from QML. The premise being we're going to make a class, and then when we click this button, we're going to call a slot from that class. Let's take a look. All right, first things first, right click, we're going to add a new file here. There we go. C++, we want this to be a class. Let's call this test. We're going to make this a Q object. And once the IDE ends, there we go. Now we're going to do a few things right off the bat here. So first thing we're going to do, include QDebug. And as we go through this section, I'm going to unapologetically do the C++ because it's just assumed if you're watching this, you know C++. So first thing we're going to do is a normal function. We're going to say int, and let's call this number. And let's do a public slot. If you know C++ with Qt core, you know what a slot is and that we can actually use Qt to connect signals and slots together. So we're going to say void bark. Let's go ahead and implement these. Not a super complex program by any means. All right, so we're just going to return an int. And let's go ahead and actually do a QInfo. And we can just take this, copy, and we're just going to paste right in here. And bark would be like if you were a dog, you'd say bark, bark, bark. I don't know. I could have said meow, but yeah, I figured we show dogs some love. We're always talking about cats, so bark, bark, bark. Let's go ahead and give this a good build. Make sure we don't have any build errors. We shouldn't because this is super, super simple. Now we're going to take this class and integrate it so that we can call it directly out of our QML file. Now our QML is very, very simple. We have a column with a label and a button, and in the button we're calling the onClicked, and this is where we're going to integrate. And just in case you're wondering, let's run this, and this is what it looks like. When I click this, we're going to call that back in C++. Jump into our main. There are a few things we need to do right off the bat. Imports. We need to go ahead and include the QML context. and include our class. So let's go down under the engine, because the engine's got to exist for this. And we're going to actually, and I'm going to say add to the root context. And this takes a little bit of explaining. So I'm going to say engine dot root context. Now notice there's root objects, and it's a queue list, and root context. What's the difference between these two? Well, remember from our QML conversation, there can be only one root object. So realistically, that list should have one object in it, and it should be this window. Now Qt does in the background add some things, but for our purposes, that window is the only thing we care about. That's the objects. Root context, on the other hand, are the properties and objects available to the list of root objects. And I'm probably saying that very badly. There's a lot more that happens here, but we want to add something to the root context. So we're going to make this available to everything, you guessed it, at the root. And we're going to set a context property. Notice it's not an object, we're setting a property. And this takes a string and a pointer to a queue object. So I'm going to call this testing. And now we need a pointer. So what we're going to do is say test. We're going to make an instance of our class, and we're going to give it a reference to satisfy that pointer. Boom. So basically we're saying create an instance of our class and then take that instance and shove it into the context property. Wow, that's actually pretty cool. So let's go ahead and test this. Notice how it's called testing instead of test. You could name this anything you want. Fuzzy bunny slippers, pink kitty, whatever you want. But I'm just calling it testing. Let's jump into our QML. And I always like to give it a good build just to make sure I didn't goof something up. We got a good build here. So let's go in here. And first things first, we're going to try and call a slot. So let's call that. We're going to say test, and before we even finish typing, IntelliSense is already popping up and seeing our backend class. Testing dot. Notice how there's bark, but there's no number. We look at our class here, number. It sees bark because it's a public slot, but it does not see number. From there, you can pretty much figure out that QML likes working with slots because under the hood, it's doing a lot of connecting of signals and slots in the background. Save and run, and if I bring up the app output, I go ahead and clear it, and we can go bark, bark, bark. So as soon as I click it, it works as expected. Now, let's go ahead and try and call our normal function. And we're going to say, cannot call a non-slot must be a property. Now notice how I'm saying it must be a property, not so much that it must be a slot. We're going to cover properties in another video, but I'm just going to demonstrate if we try to call a normal function, bad things are going to happen. So I'm going to say var num equal testing dot, and IntelliSense is not seeing it, but I'm going to call it anyways. Number. Let's go ahead and print that number. And let's see what happens here. Now, this is the confusing bit, and I'm going to slow down. I'm going to build. We get a good build. See? Compile actually built the executable. So let's go ahead and flip over to app output, and let's run this. Bark, bark, and then, uh-oh, type error, property. Notice how it's calling property, number of object, and then it has the actual pointer is not a function. And this is where people get really confused and really upset because they go, it is a function. I'm literally looking right at the function. But it's saying from QML, it is not a function. All right, what's happening in the background here is we've taken an instance of test, thrown it into the root context, which means it's available to everything. And I'm going to put it's here. And I'm going to say test class it's here, meaning it's right here at the root context and it's available to everything going down through scope. The problem is it's only going to take, you guessed it, the slots, because in the background it's connecting all the signals and slots together. So when you see something like something is not a function, immediately go back, check the spelling, and then check to make sure it's actually a slot. There is a way to connect normal functions, and we're going to cover that in another video, but I want you to be aware of that right off the bat. If you start seeing is not a function, that's typically what's going on. This video, we're going to connect to a signal. The interface is going to be pretty simple. We have a start button, a stop button, and a status label. So we're going to start a timer, stop a timer, and get the current timer status. That being said, we're going to have a backend class, and a signal is going to be emitted, and we're going to read, or I should say connect to that signal inside of QML, and that's how this whole magic happens. Our QML interface is very, very basic. 3 main components we have to worry about. Already got the QML queued up and ready to go. It should be dead simple. Let's go ahead and right click on sources, add new. We're going to add a C++ class. Let's call this test. This is going to be a Q object. Next, finish. And there's going to be a little bit of copy and paste going on here just to save some time. So includes Q object, Q timer, Q date time, Q variant. Very important we use Q variant, and Q debug. Now, why is it important we use Q variant? Because the data we pass back and forth from C++ to QML is going to be wrapped inside of a Q variant. Signals, we're going to say void notice. And this is going to be us posting a signal out into the world of Qt, and a slot can connect to it. We're going to say Q variant, and this is going to be called data. Now I want some private slots and some public slots. The private slot, I'm going to say void timeout. This is going to be our internal timer. And then our public slots, this is what we're going to interact with the QML. I'm going to say void start and void stop. And I see my keyboard is being super helpful. There we go. And then private, we're going to make our Q timer. Let's call this M timer, and a Q string, which is going to be our display. Pretty simple. Let's go ahead and flesh this out. So we're going to right click, and we're going to add that. Add that, and let's go ahead and finally add this. Now inside our implementation, we need to do a little bit of a connection. So we're going to say connect. Let's go ahead and go M timer. We're going to connect to the Q timer timeout. So we need the timeout. And we're going to connect it to this object, timeout slot. Pretty straightforward, pretty simple. The rest of this is pretty much just configuration. So I'm going to say M timer. And we want to set the interval at 1 second. And then M display. And then let's going to say Q info. And actually, you know what? Let's just do the display, make it easier on us. There we go. And then we're going to go ahead and emit our first notice. So we're going to say emit notice, and we're going to say Q variant, and we're just going to wrap our display in that Q variant. Now, before we get too much further, I actually want to go back, and we're going to hook this up into our root context. Again, need our imports. So I'm going to paste those in there. The QML context, QDebug, and QTest don't really need QDebug, but I'm going to add that in there anyways. Let's go ahead and test. And then we're going to say engine, and I want to do a root context, and we're going to set context property. It's very, very almost exactly the same. Actually, it is the same as the last video. And let's go ahead and go test. So we're just going to give it a reference to this instance of the test class. So nothing on the back end C++ side is really changed. Now we can go in and start playing around with this. And I'm going to flesh this class out a little bit more. Go into our timeout. I'm going to say display. And I want Q date time. And let's go with current date time to string. And then we're just going to grab a little copy and paste action here. So every time that timer fires, it's just going to get the current date time, update the display, emit the notice, and we're good to go. So let's go in here and let's say display starting. This is when the timer is actually going to start. And let's go ahead and do a bang. Just going to do a QInfo, and then we're going to emit our notice signal. And then timer. We're going to go ahead and start that. And we can pretty much do the same thing here. We can grab this, copy paste, go ahead and stop. Ta-da! So let's change this around so it actually makes sense. Very, very basic C++. So our test class is going to create, we're going to connect our signal and slot, we're going to configure the timer, emit our initial display. When that timer fires, we're going to actually update it with the current time. Actually, I'm getting the current date time. And emit our notice, and then starting and stopping the timer. Very, very simplistic class. Give it a good build, make sure we didn't goof anything up. I'm actually going to run it just to make sure it actually does fire up. Now we can jump over to QML land. Notice I've got this right here. This is the root context, meaning that timer, not the timer, the test class that has the timer is available at the root context. We're going to do a few things. First off, we're going to jump down to our buttons here. We're going to say on clicked, and I'm going to say testing dot, and this is the start button, so I want to go ahead and start that timer. And we can also say on the stop button, on click testing dot, and I want to go ahead and stop that. Save and run. Let's look at our app output here, and we've already got that QInfo. I'm going to clear this. Go ahead and click. So starting, and we can actually see the timers firing, and we can stop. What we need to do now is update the status. So let's go in, and we're going to actually kind of violate my own little rule here. I don't like working with connections, but this is a perfect example of why you would. So I'm going to say connections, target, and you guessed it, our target's going to be testing. And this is our C++ object on the root context. So we can actually connect to this because it is a Q object and it has signals and slots. Now we have a signal in here. Ta-da! Notice. And in QML land, let me bring this up, we can just simply say on, and then whatever our signal name is, in this case, notice. IntelliSense really didn't help us, but I think we can get through it. So we're going to say log. And then let's go ahead and update our status. So we're going to say lbl status.text equals, and this is in case you're grasping at how we're going to get that data. It's right here. So any parameter coming back from the signal is really the variable we're going to get. Now notice it's a Q variant, very, very important. So we're going to grab that Q variant, and we're going to say data. Very, very simple. Now, sometimes the editor helps us out, sometimes it does not, and it has no idea what we're even talking about. Let's go ahead and give this a good build. No compile errors. Save, run. Let's pop this up. Let's go ahead and start. Ta-da! We have now successfully connected signals and slots from C++ and QML, and we can call those slots directly. The previous videos had a bit of a problem, and that problem was putting something, well, globally is not really necessarily the best design practice. So what we're going to do is we're going to actually register a C++ class. So first things first, let's go in here. Let's actually create our new C++ class. And I'm going to just call this test, our handy test class here. It's going to inherit a Q object. Once the IDE catches up with what we're doing, there we go. I am going to just add some includes here. So we're going to say QDebug, QVariant, and we're going to do QRandomGenerator. So this is going to be a very, very simple class. I'm just going to say void status QVariant, and we're going to say data. Remember, because we're passing back and forth to QML, QVariant is pretty much the standard way to go. I'm going to grab this. And let's say void work. Again, going to be super, super simple. Right click. We're going to add our definition in there. Let's go ahead and go right here, and we're going to basically just generate some sort of random number. So I'm going to say bool, okay. And I'm going to say toInt, and we're going to actually double check to make sure that actually cast the way it was supposed to. I'm doing some basic checking here. And if it couldn't cast, we're going to say not a valid number. Otherwise, we want to do something a little bit super special here. So I'm going to say int, and I'm just writing some pseudocode. Does not really matter. We just want to generate something. Say rand equal q random number generator global. You could definitely use this to impress your friends with just how unproductive it is, but I'm going to create a bounded number up to 100. Num out is going to be our num in times that random number. So we're basically just generating a random number, multiplying it by whatever we said we wanted to do. So if we said, hey, 3, and this generates a 10, it's going to return out a 30. And then I'm just going to do some QInfo just so we can see what's going on under the hood. Copy and paste is our best friend in the whole wide world. In case you're wondering, yes, in later sections we are going to actually do some productive C++ that actually does actual work. Got to use the word actual as many times as possible. Because this is not it. This is not going to do anything other than just generate some kind of crazy number. All right, status. There we go. And we're going to say QVariant because we're passing back to QML and we want our num out. So kind of following the logic here, QML is going to call this slot work with some sort of number. We're going to generate a random number and then multiply it by whatever they said they wanted. And then we're just going to emit a signal. So what's so special about this? Absolutely nothing. I just wanted a class that we could work with here. So now the special part is really here. And I'm going to go in put some comments, and we're going to go ahead and include. And I want the QML context. And we're going to go ahead and include our test class. This is where what we're doing is going to deviate from previous videos. And I'm going to give us a good build just to make sure we didn't goof anything up. Save run just to make sure everything works. Rest assured we should have no bugs. Right here, this is what we need to do. We're going to register a QML type. Or I should say a type in QML. We do that by using some very ugly verbiage here. So it's going to be QML register type, and this gets kind of ugly. We're going to say test, so we're giving it the template of the test class, and then we've got some things we need to do here. So we need to give it some sort of URI. In this case, it's going to be com.company.test. That's basically the namespace that we're shoving it into, but it's not really a namespace. You got to be kind of careful when you say that around people. Then we're going to give it a major version, a minor version, and we need some sort of name that it can be used by. All right, let's give this a good build, make sure everything links. Once we get to this point, this class can be created in QML. Now this is different than previous videos where we've actually created an instance of the class and then shoved it into the root context. What we're doing now is we're saying this type test, this actual class, can be created inside QML. And let's go ahead and demonstrate that. First things first, we need to go up to import land. I'm going to say import our class / type. So really what we're doing is we're importing a type, not specifically a class. And this is what I mean. So we're going to say import, and here we're going to actually put in the URI. So we're going to say com.company.test. And then, of course, we need versioning. Now in Qt 6, versioning is supposed to go away, but we're not in Qt 6, so we have to put our major and minor version. That is exactly how this happens in the background. Somewhere, someone has put something like this, but it has a different URI and a different version and a different name. So once again, to recap, QML register type is going to take our C++ class type, and it's going to make it available using that and this name and this version. So as long as you get those, like I said, it gets a little confusing. You have to import using the URI and the version. Now comes the fun bit. What we can do is we can go in here and we can say, I want to actually create an instance of that now. Now, if we follow IntelliSense, notice how suddenly it sees it. And we can do something like this. We can even give it an ID. This is extremely cool. All right, so let's play around with this and let's see what's going on here. We've got our test class. We have a signal called status, so we know that we can do an on status. So let's play with that. And it actually sees it. So when you type on, it's going to look for all of your signals that are available. Notice how we have an on destroyed, on object name change. Those are injected in there for us automatically, and on status. Beautiful. So we can actually play around with this now. And I'm going to say LBL status, which is this label down here. We're going to change that text. In case you're wondering where I'm getting data from, you guessed it, it is the signature of the status. Let's go ahead and look at that real quick. Right here, there's our signature, data, qvariant data. So it's going to take that name, shove it right in there, and make it available for us. That is extremely cool. Let's go down to our button, and let's make this work. So I'm going to say var num math. I'm just going to make a purely random number. Random, and we're going to say, or actually round. And I'm going to multiply that by 100. And then we're just going to say test.work. Now this is different than previous videos, because what we're doing here is we are actually creating this inside of QML. So it's not available up here. It's actually available in the context of our window. It's not up in the root context. So we could actually create different versions of this in different QML files. This is extremely cool. We can even give it an ID. We can hook into the events, and we can call the slots directly. Let's go ahead and test this. Save and run. Very, very cool. Once you get it down, it's very easy. Some takeaways from this. First and foremost, signals and slots were not working with public and private functions. And you guessed it, go in here. You have to follow this QML register type, give it the class type, give it a URI, major, minor version, and a name in QML that you can actually create. That's the actual QML type name. We're going to do a fairly complex example, and I'm going to do this end to end. So you're going to see every single little flaw and mistake I make. You may hear some bloopers. You may hear me lose my temper at the keyboard because it's not been cooperating today. But we're also going to introduce the concept of QProperty. If you go all the way back to the first video, I talk about how it's looking for properties, and we're going to really talk about that in depth. So what we're going to do, we're going to take this QML interface. It's going to have start, pause, resume, and stop, and it's going to interface with some machine in the background. Now, this machine could be anything, but we're going to build it from scratch in C++, and it's going to have some of this functionality. And we're going to get real-time progress and all the other goodies. Let's go ahead, dive in, take a look, right-click, add new, and I want to make a C++ class. Let's call this machine. QObject. There will be copy and pasting because there is a lot of code we're going to chew through here. So let's jump in. I'm going to try and blast through some of the boring parts here just to not waste your time. So I'm going to put some includes, QObject, QTimer, QVariant, QDebug. All of those should be self-explanatory. Now, what we want to do is we want to have some signals, some slots, and some private stuff here. So let's go ahead and jump in there. I'm going to say public slots, and let's say private slots. And let's make some private variables. QTimer, let's call this mTimer. And int mValue. So in case you've already guessed, we're going to use a timer. It's going to kick off certain intervals. So our private slot is going to be this timeout. And that's where we're going to handle the actual timer. Now some signals, right off the bat, what we want to do is we want to have some things like progress, started, stopped, resumed. So I'm going to say, actually I'm going to jump down to public slots first. Void, and our slot's going to be start. Thank you, keyboard, for ruining my video. There we go. Void stop. Now we want void pause, void resume. You know, some basic functionality you'd expect out of a machine. We can take these, kind of copy and paste in here, and we can say, all right, I want to know started and stopped, paused, resumed, and I also want a progress here. Those are going to be our beautiful little signals. And you know what? I want some normal functions too, because gosh darn it, why not? So I'm going to say value, obviously going to return an int, and because we have that, we want to do a void set value as well. Now, you might already be looking at this going, now wait a minute, why are you adding these when we've already talked about they have to be a slot? Well, they don't actually have to be a slot. Remember, going back from our conversation, they have to be a property of some kind. So let's go up here. Right next to this QObject macro. We don't really go to this little area very much, but we're going to today. We're going to make what's called a QProperty. QProperty has some special verbiage. Q property, and notice how it wants a type, read, write, and notify. So what are we talking here? We're giving it some sort of type, a name. So we're creating a variable basically, but then we have to do a getter, a setter, and then some sort of signal. That's right, we're actually making a property that can be consumed by QML. So I'm going to go here, just double click it, it puts all this out here. I'm going to change this to int, and I want this to be workload. And for the read, I'm going to say value. So read is when QML says, hey, what is the value here? Notice how IntelliSense tries to help us out, and this gets a little frustrating when you're working with it. It tries to actually switch things around. I'm going to say value. Stop doing that. So I'm going to copy. Sometimes you got to force this to do your bidding. Value, and then it automatically does set value. I'm going to uppercase that, but then suddenly it flips it around. Oh man, that gets frustrating. Sometimes this does not help us out at all. So how do we work with this? Very simple. You can do it off the screen and just copy and paste, or you can sit here and fight with the editor. Sometimes I'll actually comment it out, and then I'll say, okay, do my bidding, editor. Notice how because it's commented out, it's not automatically changing it around. So why am I not trusting the editor? It's not that I don't trust the editor, I just know what I want and how I want it. And the editor is, well, just kind of bumping its ugly head up and saying, do it the way I want it. I'm just showing you that you can do it however you want. Comments are your friends. You can also do it off the screen and copy and paste. But if you start fighting with the editor, that's all you need to do is comment it out. All right, short version, Q property. A property has multiple parts, but you don't necessarily need them all. At a minimum, you need a read. So you can say Q property, the type is an int. The name is going to be workload. If QML wants to read the property, it's going to call value, which is, ta-da, right here. Notice that is not a slot. If QML wants to write the property, we're now talking about property binding in QML. We do set value, which is, ta-da, right here. This could be a Q variant, but we're really not going to specify that. Now, realistically, this should be a Q variant because it's coming back from QML, but I'm going to demonstrate it doesn't necessarily need to be. Notify, you guessed it, that's our signal right here. So we have a design pattern we have to stick to. Read, write, and notify. And this confuses people, but it's very simple. Read, write, notify. So getter, setter, setter. Let's start over. Getter, setter, and notify, which is just simply our signal being emitted. Has a lot of ugly definitions and all this little helpful stuff, and the editor tries to pop up and help you, but really that's what it boils down to, is a property is a read, write, and a notify. As long as you have those in, you're good. Let's go ahead and start fleshing all these out, and I'm going to go here. Just going to actually right click and add all these in super quick. Now I should note this is not necessarily going to be a perfect bulletproof kind of application. I'm just showing you how to work with primarily a C++ type in QML and the Q property. So you may actually find some bugs in here. This right here is actually one of them. If you talk to some official or an actual employee of Q, they're going to tell you that should be a Q variant. I'm just showing you, you can do it. You may get some disastrous results. All right, now that we've got that, let's jump into our code file here. And I'm just going to say mtimer set interval. And if me typing starts taking too long, I'm just going to start copying and pasting. So I'm going to say connect. We're going to connect that timer up. Mtimer is our object. Our signal is going to be the QTimer timeout. Destination object is this, and our slot is going to be the machine timeout. There we go. Very helpful that the IDE thinks we want those extra parentheses in there. All right, so the value, this is our getter. this is where we need to actually return a value. So I'm going to say QInfo returning value. Now our set value, this is where QML says, hey, put this in there. So I'm going to just grab this. Setting value, and I'm going to say m value equals the data. Now because we've changed that underlying value, we actually need to emit our progress. That's our notify of the Q property. So if you look just at what we have here, that is our full life cycle of this property. We have a virtual variable, this doesn't actually exist, called workload that QML will work with. It's going to expect an int type. Its read is going to be the value, its write is going to be set value, and its notify is going to be progress. So once you get all of that wrapped around in your head, you now fully understand Q property and how powerful that is. All right, let's dive back in here, and we are going to flesh the rest of this out very, very quickly. So start, I'm going to say m value equals 0, set value, m value. Probably didn't really even need to do that because we are setting it up here. So I could have actually just done set value 0. And then I'm going to go, that may come back to bite us. I'm just kind of winging it at the moment. I was looking at my notes and I was looking at that and I went, wait, that doesn't make any sense. So I'm going to go ahead and start that timer. And then I'm going to say emit started, just so we get some sort of feedback in QML. Stop, pretty much the opposite of that. I'm going to get rid of this. I'm going to say timer stop. Then I want to emit stopped. Pause. Pause is pretty much the same darn thing. Actually, we're just going to make it the same thing. And then resume. Bear with me one moment. Pause. There we go. Resume. We're going to emit resumed. All right. Got those in place. Now our timeout. Nothing super special here. We're just going to say m value. And then we're going to emit a progress. Again, this is not super bulletproof code, but we're just going to make it somewhat functional. M value is greater than 99. Then we're going to go ahead and call stop. Just kind of streamline that a little bit. Let's go ahead and give this a good build just because I'm a little bit nervous. I deviated from my notes. All right, let's go ahead and make sure we get a good run. Now we're going to wire all this stuff up in QML. All right, let's go in here, and we are going to jump right in here, and we're going to register this type. So actually, first things first, we need to actually include it. And QML register type machine is our type. Now we need to give it the big, what I call the ugly code. To avoid naming conflicts, Qt recommends you use your company's URL backwards, or URI, and then the actual name of the thing that you want, just in case you come up with a great idea and someone else comes up with a great idea and they're both named the same thing. All right, now that we got this type in here, save, give it a good build just because I'm nervous. Make sure it actually starts up. Now we just need to wire up this QML. All right, moment of truth. Fingers crossed. Let's jump in here. First things first, we need to, you guessed it, import. So we're going to import com.telesense is not helping us out, company.machine. This is going to be version 1.0. Once we've got that in there, well, you guessed it, we can actually go ahead. Let's go create our machine. Telesense suddenly sees it. Bang, there it is. Let's give it an ID, machine, and I'm just going to start hammering the rest of this code out very, very quickly. Component uncompleted, so when this window is completed, I want to actually update that progress bar. I've got right here, ta-da, progress bar. Say progress bar dot value equals machine, pay special attention here, workload. Does that look super familiar? Workload, that's part of our Q property. So when we go into our actual machine, Q property type is an int, name is workload. So that's what we're going to be interacting with. So what's happening under the hood when we go in here and we say the progress bar dot value equals machine workload, we're actually calling the read that, which is calling value da da da. Whew, boy, that gets a little confusing. Now we're going to really just completely flesh this thing out. We're going to work with our signals, and we got a few of them. So we're going to say on started, on stopped, on paused, and let's go with on resumed. And last but not least, I want on progress. If you're wondering how I'm getting these, basically take your signals from your class, these guys, doo-doo, and put the word on in front of them. And then automatically capitalize it. That's where it's getting it from. Qt does all that automatically. I'm not a huge fan of automatic things because then you're left with questions like, no, wait a minute, how'd you get this? Isn't it called started? That's basically all it's doing is slapping the word on and then uppercasing the first letter. All right, so now we just need to work with our interface. I know all these things, but I'm going to recap anyways. Pretty self-explanatory. Labels called LBL status, progress bar is progress bar, and then I've got some buttons. Button start, button pause, button resume, button stop. Let's go ahead and fill these out. So on started, I'm going to say btn start dot enable, just going to work with our interface, equals false. Why? Because we're starting this. And then we want the btn stop dot enabled equals true. Same thing with pause. We're going to say we want to be able to pause this. And then we don't want to be able to resume because we are currently running. Resume is not something you do when you're running. So, and then let's go ahead and change that status. I'm going to say LBL status dot text started. And we can just pretty much copy this so we don't have to reinvent the wheel and paste it right in here. So when we're stopped, we want this to be false. We want the stopped. Actually, am I in the wrong spot? I am in the wrong spot. If we're stopped, we do want to be able to start. Sorry about that. We want to not be able to stop because we're already stopped. And pause, well, we don't want to be able to pause. Resume, we don't want to be able to resume. And let's go ahead and set our progress bar. Why are you acting that way? Progress bar, there we go. Then on paused, I'm going to just paste that in there. Pause, we don't want to be able to start. We do want to be able to stop just in case they're paused and they go, you know what, I just want to kill this thing. And pause, false obviously because we're currently paused. Resume, let's let that be true. Now actually I think I got a bug right here. I do. All right, so if we're started, we cannot start, we can stop, we can pause, but we cannot resume. Just recapping here. If we're stopped, we want to be able to start but not stop or pause or resume. If we're paused, we want to not be able to start, can stop, cannot pause because we're already paused, but we do want to be able to resume. Ooh, that gets bloody confusing. All right, and last but not least, resumed. False, true. we do want to be able to pause, and we do not want to be able to resume. So basically just playing around with the GUI, making sure we got everything. Progress, we are almost done, I promise. And we're going to say progress plus and machine dot special attention to the variable name workload. Notice how when we go into machine though, we have a whole slew of things we can play with. We don't want to call timeout. You may see that. You don't want to play with that because of scope, the way we've got it in there. And what I mean by that, ta-da, it's actually private. We don't want to play around with that. Let's go here. Workload, and we're going to say plus some sort of %sign. And then progress bar dot value equals, and I'm going to say the machine dot workload times 0.01. That way that'll be beautiful. Now we need to actually turn these buttons on. This is the last thing. So button start is going to be machine dot start. And then we can actually just copy and paste this, make it super, super simple. Naming convention, if you keep them pretty simple, this will be lining up just beautifully. All right, let's give this a double check before we do our initial maiden voyage. We've got our import, component uncompleted window. We have got our progress bar synced up, and we've actually made the machine, given it an ID of machine, and we've hooked into all of those signals. Ooh, that is a lot of typing. Our buttons, we're actually controlling the machine, start, pause, resume, and stop. Let's go ahead and give this a run, see what happens. And place your bets, place your bets. Is this thing going to work? Start, started, and there it goes. We can speed this up by adjusting the timeout on the timer. We can actually pause it. It is at, let's say, ta-da, about 8%. We can go ahead and just talk for a minute and talk about how beautiful and elegant this interface is. And you know what? Done listening to Brian. Let's resume it. And it picks right up where it left off. We can pause it again, resume it again, and we can stop it. And then we can hit start and start all over again. So this is kind of a complex example of something you can do with very introductory knowledge of QML and some C++. You can actually make some pretty complex interfaces. Now in a real world example, let me go ahead and stop this and close it. This machine could be hooking into actual APIs and reading serial ports or reading USB ports or whatever, and you have some back-end machine like a giant water filtration system or something like that. But the big takeaway I want you to focus on is Q property is your friend. Everything in QML thinks it's a property. Properties can have read, write, and notify. At a minimum, you need a read, but I would suggest do read, write, and notify for just about anything you do. And it's very, very simple. A read returns a value, a write sets a value, and notify is just simply a signal.